In this video, we're going to look at the classify and recode processor methods in RAMP. I'm going to go through each of these one by one so you can see what they do. So let's first look at, I'm going to add a data set that I'm going to use as an example of the first processor method. So let's render this data set that I've just added. And immediately I can see something's wrong. If I click around in here, you'll see that I can tell that there's real data in here. There's real values, but things seem to be, there only seems to be two values in the display. Let's look at the statistics for this. It's telling me that the no data value is 0, yet I can see quite clearly that the minimum value is negative 9999.99. And if I click up here, I can see that what's coming in this purple color is actually this negative 999.99 value. So I strongly suspect what's happened is the no data value in my raster is in fact correct. So the first processor we're going to look at resets that. Let's just do that now. I'll open up, so the first processor method, I'll open up Classify and Recode. And the second one down here is Override Raster No Data Value. I'm going to pick this raster and I'm going to say, look, the no data value is actually negative 99999.99. And I'll click OK. You'll see now that the raster thinks that the no data value is now negative 999.99. However, the statistics are still incorrect because it's including that value in the minimum. So what I need to do is update the statistics. And now this is looking better. I've got a valid histogram. Now that I've got that, let's go and render it again. And you'll see that the values out here are now coming in and being recognized as null values, and the rest of the data set is coming through properly. So if I wanted to save this back out to a file, I'd need to use a writer and rewrite this file again. Okay, so that was the override raster no data value. Let's look at Recode Values next and see what that does. So I'm going to add one of my favorite terrain data sets again. And what we'll do is we'll use the terrain analysis tool to create the topographic index for this particular terrain data set, terrain raster. Here's my topographic position index data set, which we can use to classify different slope positions, high slopes, medium and low slopes. So let's go to the histogram here and firstly convert this into 3 bins. Okay, now I have 3 bins. I'm going to save this histogram out. Save definition to file. So let's call it here classification bins.bins. Okay. All right, so you'll see that this actually has 4 values in there. Let's leave it like that. And now I'm going to go to the Histogram Editor and open this histogram file. In fact, I could do the same thing here. But I'm going to instead use that file because it's already got the right bins. I'm going to give this a lookup value. So essentially what this is doing is it's saying anything from these values give a value of 1. Anything with these values give a value of 2. Anything in this value range give a value of 3. And anything in this value range give a value of 4. And I'm going to save that histogram definition file. Let's just open it again to make sure that has saved. Yeah, 1, 2, 3, 4. Okay. Now that I've got all this information, I'm ready to use my Recode. So Recode Values is asking me for the input raster. We're going to use the topographic position index raster, and it's asking me for a histogram file that defines what the lookups are, so how to group the data and give it a recoded value. It's going to ask for it. I'm going to create a new raster. Am I going to process the null values? No. And retain the original value on no lat true. Okay. There you go. So now I've recoded this raster into those bins that I created. So if I look at the greens, have a value of 3. The light blues have a value of 2. The purples have a value of 1. What if I wanted to change these splits a little bit? So let's go back and look at the histogram definition editor again. And let's try to change this a little bit. So let's do from 0 to 0.5, from 0.5 to 0.75. Actually, let's make this 0.25. 0.25 to 0.5, 0.5 to 0.75, and 0.75 to that maximum number. Let's save this histogram definition file again, and let's apply it again using the Recode method. So there you go. That's how you can use the Recode method in the Reclassify Recode processor to essentially have a lookup of value ranges and recode it to an output range. So it's the basis for, I guess, classification of data. The next method we're going to look at is normalizing data. So statistically, when you normalize data, you take a distribution, you calculate the mean and standard deviations of the distribution, and then you reduce all the values in the original distribution such that there is a mean of 0 and a standard deviation of 1, and you score all those values into that sort of range. So it's a way of normalizing a distribution. That can be useful if you've got data sets that have different values, but you want to be able to apply the same types of numerically based processing to them. So you might want to normalize the data first and then apply subsequent steps to that data that are agnostic to the original values of the distribution. So let's go choose this raster. And okay. So here is my normalization of I have a nice normal distribution here. Normalization of the topographic position index. And it looks the same. In fact, when I click on it, you can't see any differences, except, of course, that if I look at the statistics for this normalized data set, the Z-scored data set, I can see, in fact, that my mean in this case is very, very close to 0, and my standard deviation is 1. So that's correct. The next one we're going to look at is the rescale. So, for example, I might want to take my bathymetric data set and I want to rescale it so that the minimum and maximum values in the data set 0 to, say, 100, and scale everything linearly between those new minimums and new maximums so that the new min and max of the output data set is a value of 0 to 100. This is another kind of way of standardizing the values within a particular raster data set so that you can apply subsequent numerical processing to that data set that's independent of the original extents of the data set. So let's do that. 0 to 100, create a new raster. There's the rescale. If I render it, looks pretty similar. But now when I click on there, I have values that are in the range of 0, I mean, this bottom corner, 0 up to 100. So these values would be high here, 92, that sort of thing. You can see that down here. Okay. The remaining methods in the Classify Recode are really here for programmatic access. You can do all of the next 4 of these methods. You can do that within the graphical user interface, but if you wanted to say do this programmatically, call it from a batch script or whatever, these methods are there for you to do that. The first 3 are to generate histogram files based on either a fixed number of bins or a fixed width for each bin, or in fact using a definition file by which the raster will be binned into. So I'm not going to demonstrate these, but they're functionally the same as using the histogram definition editor, or in fact the histogram specification dialog box that's available through the graphical user interface. And here you have number of bins, fixed bin width. Let's just look at these quickly. So I want to bin this into, say, let's say 20 bins. Yeah, that's what my new histogram looks like. Or I might want to give it a bin width of 1. And that's what my new histogram looks like. The user-defined ones have a fixed from value and to value that you create in the histogram definition editor, and when you apply it to the processor method, it will update the count values in here as well. All right, let's look at the last one in here, is generate raster statistics. So again, this is something that's available in the graphical user interface, but it's only here really so that you can programmatically call it. All it does is allows you to pick an input raster and an output file, and the statistics for that input raster will be written as a text file to the output file that you defined. Let's have a look at what that looks like. This is essentially what will be the contents of the output text file. It'll have the name of the raster dataset, cell size, rows, columns, the spatial extents, the no data value, min, max, mean, standard deviation, and kurtosis. Everything that you already see here in the raster information box here. So that was a quick introduction to the Classify and Recode processor in RAMP. I hope that's been useful for you.